So I'll be here waiting until you tell me that it's been received, okay? It says I'm online. I'm online. Okay, so okay. No, but it's showing something strange here. Yeah, but yes, it's not showing the proper things here. I think it's is it showing the properly? And yeah, so you can see properly, fluidly. Okay, no, it has to be like this. So these are the tests that we were doing yesterday. So no, it's not going. I don't understand. Let me see. So now you should hear me. Okay, so now you can hear me. Yes. Okay. Yeah. So I can see here the sound that it's properly. So let's go. Let's start. Let's go straight to the point because otherwise we are very late. So let me just say hello to many of the people that is there on the chat. For example, Robotics, who was the first one to arrive. Der Kaput, as always, there trying to learn. Sri Arul, hello. How you doing? Amon Lewinstein, hello. And Christian. Christian is the intern from the construct and he is one of the creators of this notebook. So hello Christian, he is going to be answering your questions as the same as Alberto. Alberto is one of the members of our team and he is also on the chat answering your questions. Gianfranco always on the live class, nice to see you. The Bose Tech is there. Matthew Hinton, also another one that always coming to the live class. Hello Matthew. Gregor Gatwick, hello, how are you? and many other people. Let me say that Mohamed Omer, hello, Mechatronica Maxima, as always, also coming here, Chabri Meditana, yeah, I think that more or less there are, most of the people is there, so very well, very welcome. Remember that we are going to start practicing, and today we are going to learn how to create a project of ROS, so in a packaged way that you can keep it in a very organized way, so you can share with other people and they can reproduce your same results. And we are going to see how to create the different parts and how to package everything. Very well, so let's start, and today is very special because we are not going to start from a ROSject. So what we are going to start is from a PDF document that we are going to use as a guide. So the first thing that I'm going to do is to share this PDF. So then you can start following with me, of course. We are going to follow together this PDF and we are going to be practicing and doing those steps. Okay, so I need you that you stay with me, following, and then doing. For doing, you need to install nothing in your computer. The only thing that you need is a web browser, the one that you are using right now for watching this video. And then I'm going to tell you to go to some addresses, and then there is where we are going to construct our ROS project. Okay, so let's start because it's very late. Then let me share with you the link of of this PDF. So you have to download this PDF and then you will have as a reference for later. Then I'm going to show my PDF on the screen so you can read it with me. Okay, so here, copying the link, let me copy this link. I'm going to copy the link on the chat of the transmission and put it there. Okay, there it is. So I hope that you can, okay, I don't know if it's going to allow us because it has kind of, the chat has kind of cut it, the link. Oh yeah, it works. Okay, so I can see that it works. Great. So please, everybody, go to that link that I just post on the chat, click on there, and then you are going to get a PDF. What is the PDF that you are going to get is this one. So you're going to get this PDF that I have here already open for you, and we are going to follow all the instructions in this PDF in order to create our own project and include the documentation, the simulations, the code, the data sets, everything. So we have a lot of work today, my God. I don't know if we are going to be on time. So do you have, all of you, do you have that? Then we are going to start opening the ROS DS. So we are going to create this ROS project on the ROS DS. So the first thing that we are going to do is to go to the ROS DS, and if you don't have an account, create a free account very quickly. Otherwise, you follow my instructions. So you log in into the system and then you follow my instructions. Okay, let me put here the address also on the chat about where is it, the ROS DS. Okay, so it's rosds.online. rosds.online. So you visit that link and then there you log in and so on. Okay, so let's go. Let's go and let's see here on the scene, on the web browser. So once you okay, so you have to type rosds.online and then you will get inside the ROSDS. So here it is. I have already logged in prior to the class. That's why I'm starting here. Okay, so then I have here my ROSject, my different projects. But today, what we are going to do is to create a ROSject from scratch. So here in the PDF, if we go below, then you're going to understand what is a ROSject. A ROSject is a ROS project, is what we call a ROSject. And it contains, it's a way of packaging a complete ROS project that contains simulations. It contains ROS code that is going to be executed on your robot, data sets, and documentation. So a ROSject can contain any of those. It doesn't have to contain all of them, but it can contain any combination of those. So then we are going to learn how to create that. And why it is interesting to have that? Well, because by having a ROSject, then you can reproduce your results in the future based on what you have already constructed. You can, for example, share this project with somebody else, and this other person can also reproduce those results. Or you can, for example, you can update this ROSject from the current version to a newest version by touching the minimum amount of things. Or you can transfer only the important parts, the ROS code, into the robot without messing with all the rest of things like datasets or simulation code and else. So it's going to be very easy. So those are some of the advantages about creating a ROSject. Then I have put here some requirements, and in case that you don't have those requirements, have a look at the links for the courses where you can get those knowledge, like Linux for robotics, ROS basics, and love for robotics and patient. Okay, so we don't have a course still for love for robotics. The only love for robotics that you can get is from us, from watching our videos, and you can see the passion that we have for doing all this stuff. Okay, so then for this class of today, what we are going to do is to create a ROSject to control FRANKA EMIKA Panda robot. And this is the goal. So we are going to create a full ROSject containing everything and starting from zero. Okay, so then let's go step by step how we do that. First thing is create an empty ROSject, of course. So we have to create this shell where we are going to put all our code. So for that, go to the ROS Development Studio, and here, when you are here logged in, then you have to click on this icon here that says New ROSject. You click on there, and then we are going, you click on there, and then you are going to provide a name. For example, let's call it then FRANKA EMIKA Panda robot. Then, this is the name of our ROSject. Then, what is interesting is to provide a thumbnail image. And why? Because if we don't provide that, the system is going to provide a default one, which is the logo of the ROS Development Studio. But this is not, so it's going to be a mess when we have many projects. So what I recommend is that you go, for example, here to another link, and then go to the images, google.com, and then you just type here FRANKA EMIKA Panda, and then one of those pictures, for example, I like this one, so I'm going to download this one and then use it. So let's save it there and then use it here. Select the archive, select here, and then select my image as the image for this ROSject. We are going to see in a minute how to. Then we have to decide for which ROS version we are going to create our ROSject. So in this class we are going to use ROS Kinetic, but for other ROSject you may want to work with ROS Melodic or ROS2 Dashing. So all of them are compatible here in the ROS Development Studio. You are going to get an environment already configured with any of those, and you can switch between them. So let's select ROS Kinetic is okay. Then from a robot to program for, it says no robot selected. That means that you can select for some robots that are already pre-configured in the ROS Development Studio. Like for example, the ROSbot from Usarion, or the Gen 3 from Kinova, or Tiago from Power Robotics, or Summit XL from Robotnik. Since we are not going to work with any of those, we are going to select here, no robot selected. Then we are going to decide to put this either private or public. If you put it private, nobody can find your ROSject. If you put it public, so I'm going to put it public, for example, my case, and then everybody that looks here in this area, public ROSject, can find this ROSject and use it, of course. Then description, whatever. So this is just for fun. Then you press on create, and then you are going to have this screen where it says, okay, so we have created this template of a ROSject for you that contains just the image that you selected and then an empty documentation that is very, very basic one. I mean, says nothing. Okay, so then the next thing that we have to do in order to populate this ROSject is to press open the ROSject. So let's press open the ROSject. Here there are more options that I'm not going to work on those now. So press open ROSject, and then the ROSject is going to open with the empty stuff. And now we are going to go step by step and populate all the other parts. So while it is open, let me remind you that if you have any question, you can ask on the chat. So we have some members of the team like Christian and Alberto who are here supporting us for any question that you may have. And then also I will be happy keeping an eye on the chat and answering from my side. Okay, so we are here opening the empty ROSject. Remember that is an empty ROSject. So this is the step we are now. If I change here, okay, so it's already open in my case. It depends on the load of the system and how fast it will open or not. Okay, so you should reach that screen here. Then, yeah, so let me see on the chat if everyone is going okay. I see that some other people have arrived. Hassan of Khan, hello. Then RZ, always also coming to the live class. Hello, RZ. And Trexagureu. Nice to meet you. And everybody is... that is here. So I see more spectators coming to the live class. You don't have to say anything, okay? So don't worry. If you have a question, use the chat. If you just want to be listening, that is perfect. That is also okay. But remember to get all the material that we are providing here, okay? Remember, because it's free, it is going to be very useful for you. So here I have a question from Faizan that says, sir, I'm really stuck in my project, how to clean a room, but I don't want to make waypoints. I want to expand my navigation. Okay, Faizan, so sorry, but this is not the place now. So this is a live class, but for a very specific topic that is this, and this today is for creating a ROSject and some other ROSject. So you have that question, then you should send us an email about that question, or also put it into one of our videos and we'll answer that. Okay, so send us an email with your problems and we'll help you on that problem. So let's continue now. So I presume that everybody has opened up to this point, and then you have this Jupyter notebook here with some instructions. So the Jupyter notebook opens automatically every time that you open a ROSject. So it opens up automatically. Why? Because it is supposed that you are going to share this ROSject with somebody else, and then they need to know how to operate with this ROSject. What it contains, where are the things, where are the simulations, where is my code, whatever. So you need to put this documentation here in the notebook because it's going to open. But let's wait until almost the end of this ROSject to create the documentation. So we are going to deal with this. Okay, so now I'm going to close it here on the screen, on the icon. I'm closing it, and we are going to start with something else. So first I need to explain you how is the structure of the different directories where we are going to put the different elements of the ROSject. So for that, go to Tools and open the IDE. When you open the IDE, then I have here those, you can see here those directories. Actually, we call workspaces. And you can see there is an AI workspace, which is meant to contain results of trainings. Okay, this is for storing the results of trainings in reinforcement learning or any other type of learning. Then the catkin workspace, it's a ROS workspace where we are going to put inside the source all the ROS code that is going to be executed in the robot. So if you need to execute some code in the robot, then it has to come here. We are separating this catkin workspace from the simulation workspace, which is also a ROS environment, a ROS workspace, but the packages that we are going to put here are only the ones related to the simulation. Why? Because we don't want to mix the ROS packages that run in the code with the simulation packages that will not run in the robot. Because then afterwards we have to be cherry picking the packages, and that is prone to confusion, and it requires a time to do it. So it's a very bad idea. So we separate that on those two workspaces, the catkin workspace and the simulation workspace. We are going to populate now in a minute. Then we have here another workspace that is the datasets workspace. And here is where we are going to store any dataset that our ROSject requires. So maybe we need a training dataset, or maybe our ROSject is generating a dataset that can be used later in other ROSjects. So this is the place where we are going to put them. Then finally, we have this notebook workspace, which is the one that contains the documentation in the form of Jupyter notebooks. So that's a notebook that you have seen before. You can put as many notebooks here as you want. We are going to see in a minute, okay, how to do that. So let's start with the first things. The first things, let me, after I have explained to you this structure that you can find here in the document also, let's start by adding the simulation code. So we are going to, let's imagine that we want to create a ROSject that requires to have a simulation. Okay, so if we have a simulation, then we have to create it here in source of the simulation workspace. But maybe you don't want to start from scratch the simulation. Maybe we want to clone a simulation that already exists somewhere, so we can do it. So if you need to create a simulation, just come here and start creating your ROS packages. In this live class, what we are going to do is to clone from another repo that already contains the simulation. So how do we do that? Very easy. Let's go to Tools and open a shell, a Linux terminal. And then in this Linux terminal, we are going to go to the simulations workspace /source. Remember that all the ROS packages that you would like to have to create, even for a simulation or for ROS code, they have to be in the source directory. Okay, so now once we are here, we are going to clone the simulation packages from FRANKA EMIKA Panda robot. So here I have included here the command that you have to do is this git clone Panda simulation. So you can copy from the PDF the address and then come here to the terminal and do a paste. So this is what it's doing now. It's cloning, it's done. And here you can see on the IDE that the Panda simulation has started. Has been cloned, and here we have all our packages. Well, actually, it's a single package with all the directories. Great. So we have the simulation there. Remember that you would have done the same thing if you want to create the simulation from zero, from scratch. So you start creating your packages in that directory, and that's all. In this case, we have a simulation here already. Great. Next step. So we are going to launch the simulation in a minute, okay? But before launching, the simulation depends on some of the ROS packages of FRANKA EMIKA that needs to be also included into the ROSject. So that's why we cannot launch the simulation right now, because even if it says simulation, it depends on some of, oh, sorry, I pressed the wrong button. Then even if it says simulation, this simulation depends on other packages that are packages that would be included into the robot. So we need to include those packages into the ROS code, because that's code that will be executing inside the robot itself. So that is the code that goes to the catkin workspace. So let's do the same procedure. Let's go to the terminal, but now we change. So we are going to go to the catkin workspace, cd catkin workspace source, and then in this directory we are going to do the clone of the other packages. There are two clones that we need to do for this Panda robot. The first one is the Panda MoveIt config, because we are going to do a small test with MoveIt now. So yeah, let's include this one. So inside the catkin workspace / source, remember this, very important, inside the catkin workspace / source, then there is where you have to issue the first clone command for the ROS code. And then inside then we got the second one, which is the one that contains all the control code of the Panda robot. So we copy from the PDF document and add on the same location, and we issue it again. Okay, so why it says, I think I copied wrongly. Oh yeah, so it didn't copy properly. Let me see what happened here. FRANKA, I think it, oh yeah, it's because it has missed the last part of here. It's because of the PDF, copy paste. Okay, no problem, we can add manually. FRANKA ROSject, that's it. Okay, so far so good. Okay, so now what we have done is to start populating the different workspaces. On the first workspace, on the simulation workspace, we have put code related to the simulation. Remember, I'm repeating again, okay? So that code you could have created here, directly here on the editor here. You can start creating packages and edit your code. That's a lot of work for today, so we just clone it from another repo. And what is interesting about cloning from the repos is that this code here is now synchronized with the Git. So if somebody modifies the Panda simulation, we can always pull the new changes here in this ROSject. So the ROSject works perfectly transparently with a Git. Then we have first the simulation, and now we have created the code of the robot. Those are the packages that will run inside the robot. And for those, we use the catkin workspace. We put those packages inside the catkin workspace. Then again, we could have created all those packages, as you can see, FRANKA control description, FRANKA ROS. We could have created this manually, creating package by package and code by code, but that's a lot of work for a live class, a short live class, so that's why we have cloned them. There we have all those packages of ROS. So now let's do one thing. Let's go and let's compile those. So for that, you know that you have to, first let's compile the catkin workspace. You know that we have to be on the catkin workspace directory. So let's move up one directory and now issue the command catkin make. So by doing this, we are going to compile all the packages here. I know that I have put some other instructions here for compilation that include some parameters. So yeah, so you can do like this, but just a catkin make will do it. These are for optimization purposes, and really, I don't remember why they want to have those parameters, but just a catkin make will do it. So here, as you can see, it is compiling all the packages in ROS. And then once we have those, we are going to go to the simulation and compile the simulation packages. And finally, we'll be able to launch it. So in the meantime that we are compiling, let me see if there is any question that I can help you. And of course, let me have some coffee. Questions? Oh, Gloria de Felix has arrived. Very nice. Gloria, you are arriving late. Very bad, but very good that you arrived. So I'm so happy. So I'm more happy that you arrived than angry that you arrived late. So the happiness wins. Then very good. So then I have here some questions that say how to make the robots to go to the goal based on their position. For example, which robot is nearest to the goal. The robot will go to the goal instead of the robot that's far from the goal. If possible, time taken to the robot. Okay, so yeah, so I see that some questions that are here that are not related to the specific live class of today. And so this is not a forum, because otherwise we'll take all the time answering those questions. Those questions, they are not simple. They require a lot of work. So please send us our questions through email, or better write it on the comments of the video, and then we'll have we could have an answer, and other people can benefit from this. Then what else? Oh, let me check. I think my compilation is done. So, oh no, not yet. Okay, so some time for more questions. Then okay, so Christian already told you, Neil, about this. And then the email, just send us an email to info@deconstructsim.com. And in the meantime, so this is still compiling. So let me check. So let me see if I can give you any quick answer. So how to make the robots to go the goal based on their position. For example, which robot is nearest to the goal, the robot will go to the goal instead of the robot that far from the goal. Okay, so in that case, so you have multiple robots navigation in there. Then in that case, there has to be a way where those robots have to communicate. So maybe the best option is to have a single ROS core running, and then use the parameter server or a topic where there is maybe a topic that there is another node that is always computing the distance for all the robots to the goal, for example. So that's a node that is taking the position of all the robots at any point in time and computing when a new goal is released. Then this node is the only one that listens to the goal. And then when this node listens to the goal, then it computes the distance from all the robots to that goal, and then decides which one is the closest one, and then sends this goal to the specific navigation system of that robot that is closer to the goal. So every robot will have its own navigation system running. And yeah, so this master node will be the one in charge of getting the original goal and then translating this to the specific navigation system of each robot. Okay, so here we have my, let's continue with the class of today. I have the packages compile. Now we need to do a source in order to get all the changes that we got. So do a source devel setup.bash. That's usual in ROS, okay, so nothing new. Great, now let's go and compile this simulation. So we have to go back to the simulation workspace, and now only on the simulation workspace we do the catkin make. Catkin make, and it's going to compile this simulation, and it's going to use any dependencies on the previous packages that are already installed in the catkin workspace. So remember that if you have simulations and ROS code that depend on each other, then you have to follow this order. So usually is the simulation the one that depends on the ROS code. That's a proper way of creating the ROS projects. If you have circular dependencies, then it's going to be a nightmare to compile any of those workspaces. So my recommendation is that you work in order to put all the dependencies, the initial dependencies on the catkin workspace, and then the simulation depends on those only. So you can compile first the catkin workspace, and then you compile the simulation workspace, taking into account the catkin workspace. Okay, great. So we have everything here and done. So let's do another source here about the devel setup.bash. And here we have, everything run, compile and done. Now it's time that we launch this simulation that we have installed here. So for any simulation that you install here, you can use the simulations option menu here that you have on the top of the ROS Development Studio. Go to this simulation and then select this button here, choose launch file. This is the button that you're going to use when you have a simulation in your simulation workspace. Otherwise, you can use the provided simulations by the ROSjects that are already created. So if you are happy with those simulations, then you can use those instead of one custom made in your simulation workspace. But now what we are going to do is to select the Panda simulation that we have installed. So press this blue button, and then on this dialog, go to the dialog and select the simulation launch. Select that one and then press the launch button. Then a new window should appear here, and it's going to contain the simulation of the robot, if everything is okay. So here it is launching, and let me go to the document because I don't want to jump in any step that we have prepared here. So here is the simulation launching, and then we should receive something like that. We should get something like that, a simulation like this. So here it is. Then there is an robot control node has a problem. Okay. That's strange. That is strange because I didn't have any problem. Let me see. I can see that this simulation is, yeah, it's looking strange here. It's kind of looking strange. It didn't look like this to me. I don't know if this could be a problem due to the load of the CPU, because as you can see here, I have the 2 cores only, and 99% of the CPU is going to strong there. I don't know. Okay, so I don't know. Let's move forward. Let's see if this is affecting. I don't know what is this node of control, but it doesn't sound very good. This node doesn't. If it is failing, then some controllers may be failing. It's very likely because it's also robot control node. So I don't know. I don't know for that specific simulation. Okay, well, let's move forward. So what we are going to do now is to launch the RViz. Here you can launch RViz by typing RViz directly, and then we are going to try to move the robot. So the RViz is starting, and then when it starts, it opens in another window. And where can you see this window? So it's not going to pop up here because it's a RQT window. It's not a web window. So in order to watch those RQT windows, you need to go to the tools and select the graphical tools option. So if you get this graphical tool option, then in this window is where you are going to see any RQT window that you open. And there it is, the RViz. So let me put it like this, bigger. Then I'm going to do double click on the blue part, double click in order to fit to screen. So so more or less it fits to a screen. I'm also going to remove this. I'm going to change the fixed frame from map to one of the frames of the robot. So I'm going to move down until the wall frame. So now everything is nothing in red. And now what we're going to do is to add a display for showing MoveIt commands for the robot. So those steps are included here in all the images. But now what we are going to do is to add the motion planning from MoveIt. So we can use the RViz to command to the robot using RViz. So how do we do that? So here in RViz, go to Add. And then on this menu that appears, go down until you see the MoveIt section. Here it is, MoveIt ROS visualization, and then select MoveIt planning, then OK. So now it's going to configure everything for that. And here we have the simulation. Is very strange. It's very strange. Okay, so we'll see. Okay, so now we have that. Then I also had this behavior about this trying to fix everything here on the screen. And then what I do when I have this, just get rid of this part, clicking here on this square button here. So to remove that part. that's it. And now, so I got this resizing properly, more manageable and better for me. Okay, so there it is. So we have this robot in RViz with a plugin for MoveIt. I'm getting closer to it. And now what we are going to do is to select here on the motion planning option, we are going to select the planning group as a Panda arm or Panda arm and hand. You can, now by default it's just the hand because it has 3 planning groups. One is the hand, another one is the arm, and another one is the arm and the hand. So let's select one of those 2 that contain the arm because it's more interesting. We can see the arm moving. Okay, so for that, go to here to the first part on the top and move down until you see the MoveIt motion planning here. Now open it, the motion planning, by either clicking on the small arrow or the double click on the name. And now move down until we see the, let's see, the option. Wow, that's very small. Wait, yeah, I'm having some problems with my mouse. Let me see. Sorry, it was on this in the planning request. Yes, okay. So it's on the planning request here. Yeah. Okay. Let me open. Let me move down. Okay, planning group here. So here, instead of having the hand, you can click on the side and then on the drop-down menu, select one of those. So I'm going to select the Panda arm and hand, just because it's more fun. So now we have selected that one, and what we are going to do is to move using this visual marker. So we can move and select the goal of the end effector. So if you get closer to this simulation, well, not the simulation, but it is the representation inside RViz. So let me move closer here. Here I'm moving closer, and now I'm going to use those arrows to select another position of the end effector. So for example, I'm going to select this red one and move up. Okay, so I have very small space. Let me do one thing. Let me make it bigger so I can have more space here. And yes, and here also select a little bit further away. I'm trying to move. Okay, I think it's too heavy this for 2 cores only, because we are doing a lot of things here: the simulation, the controllers, the MoveIt, the RViz with all these the planners. So well, that's it. So I'm going to select this green one and move it to this side. Okay, it's not allowing me for some constraint. So yeah, so moving to the other side, and let me see if I can move it. Okay, I cannot get a good perspective with this. Okay, it's down on the ground, so it cannot be there, because otherwise it's going to collide with the ground. So make sure that the goal is not on the ground. Okay, so now I have a better perspective, and then I'm moving the robot, the end effector, to the proper location. There it goes. So there it is. So I'm going to plan from the current position of the robot to that position, to that location. Okay, for that you need to go to the planning tab and then select plan and execute. But let me put this window a little bit smaller. I think we have to use a 2-screen system, because otherwise I cannot show everything. I want to show the movement on the simulation at the same time that we press the plan and execute. So you press plan and execute, and then the plan is going to be computed, and then the robot is going to execute that plan. So you can see on the simulation how it does that. Okay, so far so good. So this is just to show you that everything is working. Okay, so that we have the robot is working. We have downloaded everything and from scratch and everything working. Nice. Okay, so let's continue now about how to create the ROSject, because that is the purpose of this live class. The purpose is not to make the movie working or so on, just to show that everything is working. I don't know what is that crash, because I tested before and I didn't find this crash on the simulation. There is a crash of one of the nodes, okay? So maybe it's not related to the simulation and it's not needed, I don't know. But yeah, so we have a crash that we should investigate. But anyway, for the case of these experiments, it does work. Okay, let's continue then. We have this to create a data set. So let's imagine that we also need to have some information. We are going to do some experiments with this robot, and then we want to record, to have some data generated in the simulation. Or we have used a real robot and we want to use that data from the real robot in this simulation. Okay, for that, we are going to use this workspace here that is called a dataset, and we are going to store a dataset in there. So you can store the dataset by generating it right now or by uploading it from another place. Okay, so let's use the method for generating it here, but uploading will be the same. Okay, so the same thing, the steps are the following. You have to go to this option that is called datasets. So click on there and then press on the button that says create. Now you can provide here any name. That's a label for your data set. Let's say joint states data, and then the folder to attach is going to be called, this is the folder in which our data is going to be stored. So okay, so let me tell you about this name. This name is going to be recognized as a data set. Okay, so it has to make some sense for you. So let me add something extra. So like joint state data from Panda. You cannot use spaces for that. And then folder to attach, we can just call it like joint states, for example. That's it. And then one description, and then we took this from the live class 60 is I don't remember, 60 or 74, and then we don't make it public. Okay, so then you press here create valid dataset name. Let me see. Okay, dataset name, I think it's for the capital letter. Yeah, I think it's for that, for the capital letter. So let me create again. Okay, there it is. So then here it is creating, indicating how the dataset is being generated. Well, it's just the directory, the structure. Okay, so now we have to populate this. So here, if you go to the dataset workspace, you can see that a new directory has been created that is called joint states. And if you open it, you will see that there is a README file. It's an empty README file. So if you open it, then you can include here any information that you would like to include into the data set. For example, data generated on the 19th November 2019, for example. Okay, so now let's include the data in there. So up to now, we only have a structure for including data. So how do we do the data? Well, we can do a data for like with a ROSback, for example. So what we are going to do is to go to that directory that we just created using the terminal, and then do a ROSback record of the joint states. So let's do it. Let's open a new shell, and then inside that shell, we are going to cd datasets workspace, and then joint states Remember that this is the directory that we have created. And then here we are going to do a ROS back record of the topic joint states. So you type this, and then this is going to start creating the ROS back. Now we can go back to the RViz and move the robot. Let me see here. So for example, we can move the robot to another place and plan and execute. Let me remove that. Plan and execute. And then the robot is moving, and while it is moving, it is generating this data on the back. At any point in time that you are finished recording your data, you can come to the terminal and then press Ctrl+C. Now you have, if you go again to the IDE, we go back to the IDE. Okay, let me see. Okay, let me minimize that one. So here on the joint states directory, if I open it, now I have my bag and the README file, of course. So I have both things. Okay, so that's how you are going to create datasets that are attached to this project. And you can see here in the dataset that your joint states data from Panda is being attached. Okay, so far so good. So now we have seen how to create the simulation code, how to create the ROS code, how to create the dataset code, and then there is more information on the PDF, but we don't have time about the datasets. So I leave this documentation to other situations, okay? Because you can attach some other datasets created in another time. But now let's jump to creating the simulation, the documentation. This is the final workspace that we need to learn how to populate. So here in the notebook, we have the documentation in the form of a Jupyter notebook. And if you go, how can we see this? Well, you can open it here on the IDE, of course, if you press double click, but this makes no sense because it's just a Jupyter notebook, so you cannot read this properly. So how do we do that? We generate new notebooks by going to Tools and opening the Jupyter notebook. So this Jupyter notebook is going to open automatically into that directory. So you can see that it contains the default, the images directory. So in case that you would like to modify this default one, just press on it and then modify. Okay, so you can modify this one, double click. Here you can see the instructions for how to modify, how to edit, and then here a tutorial from the Jupyter creators themselves. So that's not the point. So what we are going to do here is so I'm going to get out of here. So we are going to create our own documentation for this specific ROSject. And the documentation is just what I have here in all this PDF. So we are going to upload the documentation from a link. So here you can see that you have this link here. And then what you can do is to get this link, click on this link on the PDF. And by doing this, you are going to download into your local computer a tar file containing all these notebooks that we are going to upload to our ROSject. Okay, so click on the link on the PDF and get the tar file. So once you have that, let's go back to the ROS Development Studio and let's delete those directories and files that we have inside the notebook workspace. So you can right click and remove, delete here. And let me close that, or let me say yes, remove, yes, and then the default also, let's delete it. Okay, and now you can drag and drop your file from the one that you have downloaded here into the notebook workspace. So now in my case, as you can see, it is uploading the file, the tar file that contains all the documentation that I have prepared for this specific ROSject. But you don't need to do it like that. Okay, so you can create from scratch, as I mentioned here, the documentation. And actually, we prepare our live classes like this. So we open the default, and then we start modifying, and so on, so on. That's what we did. But now we don't have the time, okay? So what we are doing is just providing to you with the notebooks and the images and everything like that. So we have this start file. We need to open another terminal. And in this terminal, we go to the notebooks, workspace, and then here you have to see your tar file. So let's uncompress that. Tar xbfp, and then the notebook. Okay, there it goes. So let me copy for everyone the command that I have issued on the chat. This is because I think that is not on the PDF. I forgot to include that one. So let me copy that and go to the chat. And this is the simulation, the uncompressing command. There it goes. So because I have done this uncompress, now you can see here inside my notebook workspace, I have another images directory and another Python notebook here. Now, if I go back, let me close this one, and let me go back to Tools, Jupyter Notebook. Now, when it opens, it's going to show me the new file, that is this one, how to create a ROSject, and then if you click on it, you are going to get the notebook that is related to this live class. Okay, so this is basically the content of this PDF that we have been following. Okay, so far so good? Great, great. So let's use now the ROSject that we have, and then the documentation of the ROSject that we have. So if we continue from that point, now what it remains is to save everything. So how do we save this? Well, very simple. So we have everything here, it is contained. So you can close and close and close. So the thing is to save on this icon, and then it will tell you FRANKA EMIKA Panda robot, then synchronize ready datasets. Just say no by now, because we have a bug on that. But if you save, your dataset is going to be saved to this ROSject. Okay, so don't worry. So say save, then press yes, override, and now you can see here there is the icon. It has some blue thing that is indicated that is saving everything, and there you go. So that's it, it has been saved. So now let me show you what you can do with this. So you can go to this icon of the wall, to your list of ROSjects. And now you're going to see your newly created ROSject, this FRANKA EMIKA Panda robot. This is the one that we have created, and it's here in your list of ROSjects. So what is interesting is that if you click on it, then you will see that it's indicating, for example, that it contains one data set. So because we have attached it, and then it's showing here now the documentation that we have created. So you don't need to open in order to get all the documentation, so you can get it there. And also what is interesting is that you can share this with somebody else. So you can press here and then provide this link to anybody. So anybody who gets that link will get a complete copy of all the material that you have done. How powerful is this? How powerful is this for ROS? I mean, this is super powerful. Because imagine this for teaching, imagine this for teaching, imagine this for research, sharing the results and checking that the results that somebody says, they are actually right. For example, those are some applications for demos for your own customers, so they don't need to know anything, just come here and open in the instructions. So very, very powerful. Well, anyway, you have to decide about what is powerful or not on there. So then that's it. That's mission complete for us. So then what I would like you to tell you is that, please, if you like this material, if you like the live class that we are doing, please support us. Give us some support from your side. We need your support. How can you support us? Well, one of the things is just buying one of our ROS developer t-shirt, like the one that I'm wearing here now, today. So, like this one. This one, guys, for example. There are several models there on the shop. You can see here there is a link for going to the shop and then find different types of models and so on. Or you can subscribe to our academy that we are providing ROS courses online, very practical courses that use a similar system like this live class. So it's not just videos, it's a practical system, and we have many subjects, starting for beginners up to professionals, very difficult subjects ones also, and very simple ones, starting by Linux or Python for robotics. Or if you cannot spend any money, if you want to support us, give us a like, subscribe to our YouTube channel and give us a like, thumbs up, something like that. That would be great. Then we'll get your support. Okay, guys, so that is all for today. Let me stay here a couple of minutes more just to answer your questions that you have on the chat. Let me see if you have any. In the meantime, let me have some coffee, okay? ROS2 coffee, of course. Very cold already, very cold. Okay, let me go to the chat. I know that there is some delay between my speech and then when you receive it and then you pose the question. So let me see if there is any open. And then Marcus Buchholz says, we should spread info about the construct. Best support. Yes, that would be great, Marcus. Thank you very much for your message. I know that Marcus, he is always saying nice words about our work, so I really appreciate it, Marcus. Thank you very much. And I'm surprised that you arrived to the live class because usually you don't have time because of your job. So you mentioned in some of your comments. So I'm very happy that you made it to this one. And then Mudamar Bakir says, I have just come here. Have I missed something important? Yeah. Okay. You killed me, Muradar. Yes, you missed a lot of stuff, of very important stuff. But don't worry, because everything has been recorded and it's going to be published as we finish. Then you can reload the page and then you will see the whole video. And you can get access to the links that I have on the chat because they will appear on the chat. So you can replay, don't worry about that. Any other question? Let me see. Faizan Ali Khan says, yes, we support you, sir. Thank you very much. Faizan, thank you very much. More questions, guys. I'm still 1 minute. In the meantime that you think about your questions, let me tell you that in 20 minutes, my colleague Alberto, he is going to deliver another webinar here about MoveIt. So he's going to provide an introduction for beginners in our channel. So you go to our channel if you're interested. And why is that? Is because tomorrow is MoveIt Day. It's a whole event about MoveIt. You know, the software of ROS for robotic arms that we just used in this live class, okay? So then this is MoveIt Day, which is about events about MoveIt around the world. And then at the Construct, we wanted to collaborate with this MoveIt Day, providing this training. So all the people that comes to this webinar in 20 minutes, it's about 20 minutes, about to start, then you are going to learn about MoveIt. So if you have still time, that will be great. Then Amon says, thanks for the great class and work. My pleasure, Amon. Thank you very much. I hope that you learned a lot and that you are enjoying those things. Thank you. Thank you. Mohamed Amine says, many thanks. Okay, so many thanks also to you. And many thanks to all the attendants to this live class. For this next live class, it's going to be next week. We are going to talk about how to solve problems of navigation. You know, when you have your navigation system, everything is there working, and then you provide a goal to the robot, but then the robot doesn't move. So what is happening there? What is happening? So we are going to see a few errors and how to solve them. Typical errors, okay, when we press there and then people doesn't know why, and how to figure out why it's not working. Okay. And then, so Faizan says, my upper question, cleaning robot under dynamic environment. Okay, I don't see the question. I don't understand this. Is it a question? Is it a suggestion for a live class? I don't know. Please clarify. But we have to leave, okay? Because we have to prepare for the next webinar. And thank you very much, guys. Thank you for everything. See you next week. And until then, keep pushing your ROS learning. Bye-bye. Okay, so now I have to figure out how this is. I have to close, so let me see.